Hello students, how are you? Students, as you know that we have been discussing about finding limits in higher dimensions. And students, in today's lecture we will talk about finding limits in case of 3 dimensions. Okay, now let us take an example. The example says that show that a limit of this particular function in 3 dimension does not exist, and we have to find the limit x approaches to 0, y approaches to 0, and z approaches to 0 of this function. And here x, y, z represents 3 dimensions. Now the students, the procedure is this: for 3 variables, for 3 variable path, we now use parameter t. Okay, and the other one is always choose an axis as first path. Always choose an axis as first path. Okay, now what it says, let me explain by solving an example. Okay, by solving this particular example, first of all you have to choose the path along your axis. Along axis means first of all you have to choose along x-axis. You know that if we choose along x-axis, then that means that on x-axis, if you draw it, then along x-axis y and z are 0. Okay, then after that when you use this value in your function, then definitely if you are taking the limit up along x-axis, then your y and z approaches to 0, and there is no need to write y and z here, so you will write only limit x approaches to 0. And as your y and z are 0, so if you substitute its values, then you will get x times 0 plus 0 times 0 plus x times 0 is divided by x square as it is plus 0 square plus 0 square. And if you simplify it further, then you would get limit x approaches to 0, 0 by x square is equal to 0. Keep in mind students, here our denominator is not 0, otherwise we will get undeterminate form and we need to find some other way to solve this question. Okay, now here we get 0. Now students, in the same way, means similarly, choosing along y-axis and z-axis would give us the same answer. Okay, means if I choose along y-axis and along z-axis, then I will get definitely 0 here, because if we substitute x y z is equal to 0, then again our numerator equal to 0. Definitely denominator is not equal to 0, otherwise we couldn't be able to solve it. Okay, now students, as you know, we have to prove that the limit does not exist. So choosing along these paths mean along x-axis, along y-axis and along z-axis doesn't give us any particular value to show that it doesn't exist. So we have to choose along some sort of curve. Now let us choose along curve C. Okay, now this particular curve is basically a parametric curve. For example, I have to substitute here x is equal to t, y is equal to t and z is equal to t. As I already explained that first of all always choose an axis as first path. Actually I have to give it number 1 because our first step is this one, but our first step is this: we have to choose along our axis, and then if doesn't work for us, then we have to choose the path where we use the parameter t. But the selection of parameter t depends upon your function. For example students, let me explain it. For example, if I choose x is equal to t, y is equal to t, z is equal to t, then definitely our limit here would approach limit t approaches to 0, because here all the values are equal to t, so that's why I can only take t is equal to 0 instead of writing t 3 times. Okay, and after that if we substitute t value here, then obviously we will get t times t plus t into t and plus again t times t, and is divided by t square plus t square plus t square, because I have substituted all these values in my original function. Then after that I will get limit t approaches to 0, t square plus t square plus t square is divided by t square plus t square plus t square, and obviously student it would become equal to limit t approaches to 0, 3t square is divided by 3t square, and if I cancel it with each other, then students simply I will get limit t approaches to 0 times 1 is equal to 1. As you know students, in the previous step where I have choose the axis, I get the answer 0, but here I get answer 1. So as 0 is not equal to 1, so limit does not exist. And this is the simple way to do it. Now students, let me discuss another example, and then after that I will explain why I choose just t here. Definitely if I say we have to choose some sort of parameter t, then it could be 2t, t square, t cube, but why I choose just t? Because student, let me explain here instead of doing another example first. Students, as you know that if I choose all the variables equal to t, then our numerator would become equal to the denominator, and it gives us the answer in such a way that we can cancel them with each other, and we can find a way to solve it in an easiest way. Okay, that's why I choose the parameter t here. Now let me explain in another example where I have choose some sort of another variable. It is basically in t, but it is equal to t square or 2t or t. Okay, for example, um, if we take this example, limit x y z approaches to 0 0 0, x z square plus z y square is divided by x square plus 2y square plus z raised to power 4. Now students, as you know, the procedure is the same. First of all, we have to choose a long x-axis, means we have to select our axis and check the behavior of our limit. Now if I choose a long x-axis, then students, definitely our y and z are 0 on x-axis, so that's why our limit would only approach from the x-axis side. And if I substitute y and z here equal to 0, then I will get 0 by x square. I have written down it directly. You can also check it by substituting y and z equal to 0 in this function. Okay, then I will get the answer 0 here. And in the same way, if you choose y and along y axis and z axis, then the answer would be the same. Okay, let me write here similarly for y and z axis. Sorry. Now students, if I choose along the curve c, then what would happen? Students, if I choose along the curve c, then let us take x is equal to t square, y is equal to t square, and z is equal to t. Now students, I will explain why I choose these parameters, but let me first substitute these values in our original function. If I substitute these values, then our limit would become approaches t approaches to 0, and if we substitute x is equal to t square, z is equal to t, and definitely due to the square of z, it would become t square, and plus t times t square, yes, t square square is divided by t square plus 2 t4 plus this is z4, and means t raised to power 4. Okay, students. Now, here we will get limit t approaches to 0, t raised to power 4 plus, yes students, here it is basically 2, it is not equal to z. Okay, so I will get 2 t ki power 4, t4 is divided by, in the similar way, basically here we have x is equal to t square, and 2 2s are 4, and that's why here we will get t4. And so that's why here we have t4 plus 2 t4 plus t raised to power 4. And if we simplify it further, then we will get limit t approaches to 0, it is equal to 3t raised to power 4 over 4t raised to power 4. And if I cancel them with each other, then I will get limit t approaches to 0, 3 by 4, and it is equal to 3 by 4. As students, you know that 0 means when I approach the limit along x-axis, then our answer is 0. But if I take it along some parametric curve, then it is the answer is equal to 3 by 4. And as 0 is not equal to 3 by 4, so limit does not exist. Okay, and this is the simplest way to solve the question that involve a limit in 3D. And most of the time you are asked to find that the limit does not exist, but most of the time he just give you a question and you have to solve it and tell whether it gives a finite answer or the limit does not exist. Now students, this is all about today's lecture of about finding limits in case of three dimension. Students, see you next time. Thank you so much.